I think we initially started with IO port. From there, we moved towards ADC related stuff right now. So the reason behind that is one control register that made us to deviate from here. So let me come back to the point that we discussed before in ports, because that is our starting point. We'll come to the ADC at one point of time. So let me share my screen. This is was discussed right now. Operation of each pin is selected by clearing and setting appropriate control bits in ADC CON 1 and or CM CON registers. Actually, yesterday we have seen in ADC CON 1, we had seen list of bits. Those bits define whether which pin going to be an analog pin, which is going to be a digital IO pin right now. That is what we had seen. We had seen it or not yesterday. So we had a discussion about it. Let me revisit one more time so that you will have a clarity. AD con, it is not ADC con. This is AD con not. This is AD con 1. Right now here AD port configuration control bits we have no. These bits probably from 0, actually it is 4 bits, right, in LSB of this particular register. So if you look at this, here we have these bits are only used to define which board going to act at a digital IO and which one is going to act an analog IO. Yes or no? Right now. Yes, so these were port A pins. So this AN1, AN0 to AN7 are port A pins, so that to make them whether they are for analog or digital, we are using this register. That is what they are trying to say here. Right now. So line number 4, that is what they are mentioning here. Right. Here we have a diagram too. Right. Whenever you want to output some data, when you want to use something as an output pin, first thing is you have to write your TRISA. Right. Meaning like whether that is an input pin or output pin, that decision is made. After that, you are writing your actual data to be returned to that port in port A register. Right. When you write like that, according to that, it will work. When you want to read from that, meaning when you want to use that as an input, again the TRISA come into the picture. But when you want to set that as an input, you set the TRISA value as 1. As you set that to 1, it becomes an input pin. So the incoming input that is given in those pins are like initially latched and then they are digitized. So you can read the result from the port A. So here you are writing, here you are reading, right now. So that's how it works. So from this to control port, we have to be aware of respective port direction control register, data direction register, TRIS A, TRIS B, TRIS C. Actually, totally some 4 ports we have now. A, B, C, D, E. Actually, I 5 ports. For all those ports, we have a direction register as well as the actual data register that you want to toggle or that you want to write to that port. So when you use that particular pin as a clock input pin, that means clock for timer not, then how the circuit should be, that is given here. IO pin has protection diodes. So this is RA5 pin. This is a particular pin. Only for that pin they have this. Maybe I think it's in compare control register, I hope. Port A functions. So AN0 input output or analog input. AN1 input output or analog input. AN2 input output or analog input with the reference we have here. And then input output or analog input or V reference plus, then input output external clock input for timer not, or compare output. Output is open line type. So we have, and then RFI input output or analog input or slave select input for synchronous serial port. Right now it is also used as a chip selection pin for synchronous serial port. SSP. Probably when we use SPI, we may require this. So when we are going to interface our CAN controller using SPI, no? So in that time, we may require this. Summary of register associated with the port A. These are the register that you have to work with when you want to work with port A. First one is port A, which is going to hold your data to be written. Then TRIS A, which is a control register, which control the direction of input, whether it's an input or output. Then CMCON. CMCON, I believe this is used for CVR con. We have, right? Let us see the CMCON. What we have in CMCON. I think it is compare control register, I believe. Comparator mode. So the comparator module contains two analog comparators. Input to the comparators are multiplexed with the IO pins R0, RA0 through RA3, while the outputs are multiplexed to pin RA4 and RA5. On-chip voltage reference section comparator voltage reference module can also be an input to the comparator. Okay, these comparator module CMCON register, what it does actually, here we have comparator 2 output bits when C2 INV is equal to 0, meaning this particular bit is 0. If that is the case, 1. If C2 V in plus is greater than C2 V in minus. I think actually just they are comparing. Are they comparing analog voltage or CMCON register control the comparator input on multiplexer? A block diagram of various comparator configuration is shown in the figure 12.1. Comparator module contains two analog comparators. The output of the comparators are multiplexed with IO port pin R0, RA0 and RA3. Meaning that this RA0, RA1, RA2, RE3, these can be used as a comparator as well. Comparator means when you configure these particular registers, particular pins as a comparator pin, it will work as a comparator. When you want to use them as a IO port, meaning just simply digital IO, we have to set this pins to some value, meaning we have to configure this value using these CMCON register. That is what here they are trying to say. We'll study about the comparator later. So here what we have. Comparator mode bits. So 12.1, so comparator CM0, CM2 bit settings. Where is the bit setting we have? Figure 12.1. This is a register where we have figure 12.1. Figure 12.3. Then this is figure 12.2. I think they mean this one only. Figure 12.1. right? See, when these bits are set to 0, comparators reset. Two independent comparators. When you have this value to that, I believe we are comparators reset means this we have to set to 0. Independent comparator output. I think when you don't want to use them as a comparator, we have to make these bit to 0. That is what they are trying to say here. So then CVR con register, what this particular thing is doing. Voltage reference module. Comparator voltage enable bit. Comparator VREF output enable bit. Comparator VREF range selection bit. Comparator value selection bit. Actually, these two registers from my view, when I was doing port programming, I didn't use them. But why they have given that as a summary, that I am not sure. From our view, we don't use them, but we use them. We use this ADC con register, which is defining whether that particular pin is an IO pin or an analog input pin right now. So that is only we will work. We will take into account, right? Totally these three register: port A, TRIS A, and then ADC con. This defines particular pin is whether it is an analog or digital, something like that. And then the TRIS A is configuring the direction of the pin. Port A is writing or reading actual state of pin right now. So that is how it is used.